Good morning, everyone. Good morning. So today we discuss upon a secure hash algorithm. SHA we call this. So this is an important hashing functions used in most of the places, mainly in passport productions and all. We are using SHA algorithm. Various versions of SHA algorithm are available. Today we are going to discuss about SHA 256 mainly. So before going to the topic, anyone recap what we discussed in the last class? Anyone? Right.
In last class we discussed about MD5 algorithm, which stands for message digest file. It's a version of message digest, and it's invented by Ronald Drivers. We can give how many length of input, but it converts into a 128-bit hash function. And the main 5 topics process of it is padding, initialization, block processing, rounds of optimization, and finalization. This undergoes this process, and mainly it divides the input into 512 bits and later into 32 bits, and that process goes on. And the main disadvantage, and this was stopped using, is because the collisions. You can give the same input or different inputs to attain same 128-bit hash number. So it was stopped, and later it was replaced by SHA functions. SHA 256 and 3 is mainly used for this right now. That's it.
Okay, good Harish. Well narrated, but it is also same like MD5 algorithm, right? So this is the next version, updated version of MD5. This is secure hash algorithm. Okay, so 256 is mainly we are going to discuss. Here also the input may be any number of length. So the input may be any number of bits. The output digest. The output we call it as a digest. The digest is the fixed length. In MD5, it is the output digest is 128, 512. It is 128. In MD5, it is 128 bits output. In SHA, it is 512. The output digest is 512. Right. So here, based on the input length, it is classified into various types of SHA functions. So look into this table. In SHA1, message digest size is 160. In 224, it is 224. 256 is 256. So based on the digest value, it is named. The SHA algorithm is named based on the digest size. Okay, right. So what is the message size? So here message is our input message. The plain text we call it as a message. The message size in SHA1, the first algorithm is 2 to the power of 264. In the case of 256, it is greater than 2 to the power of 64. This type of this much length of digest message value, we have to use SHA 256. So this is for SHA 384. This is for 512. SHA 512, right? So this is the block size. In MD5, the block size is 512, right? So for that, we have to append the length, the padding bits in the multiples of 512 in the case of MD5. So here in SHA 256, so the block size is 512, right? In the case of 384, the block size is 1024, right? Then word size. What is the word size? Word size is the input length. Input length. The word size is 32. In 384, it is 64. Number of steps here, it is 80. That is, this represents the number of round functions. In MD5, there are 16 rounds. In 16 rounds, in each round, we used 4 buffers. We remember A, B, C, D, like that. Here it is 8 buffers. We use 8 buffers. Buffers are nothing but the temporary storage which stores the values, the process values, the functions outputs. It stores the temporary values, and finally it stores the final output. The buffers are nothing but temporary storage elements, right? So here also in SHA, we discuss today SHA 512. So look into this main block diagram. So here this message bits, any number of message bits 2 to the power, it is for greater than 2 to the power of 64, we use 512. For the message bit is to be appended. It is to be appended with padding bits and length bits. Here the length bits is of 512. The length bit size is 512. So that the padding bits and length bits is to be added so that the entire message should be the multiple of 1024. Okay, 1024. So that this message is divided into various blocks. This thing we named it here as M1, M2 up to Mn. Okay, so the block size is 1024 bits. In MD5 it is 512. Here it is 1024. Block size is 1024. Then it goes to various functions. Here it is 80 rounds of functions. In each functions there is 8 buffers are used. Various nonlinear functions are performed, and finally the digest value, the size of the digest is 512. Okay, so this is more secure compared to MD5 and SHA 256 and all. Okay, thank you. Thank you.
Yeah, summary. SKJ is known as secure hash algorithm. It's have 5 steps: append padding bits and append length and initial hash buffer, process message in 1024 bits blocks in 128 words, output from the nth stage in the 512-bit message digest. How it works? The algorithm takes a input a message with a maximum length of less than 2 power 128 bits and produces an output 512 bits message digest. The input is processing in 1024 bit blocks.
Okay, good Harini.